postulates and theorems. And so it says corresponding angles postulate. Postulate means that you take it for granted. I mean, you take it as true without having to make any proofs. Okay? It says if a transversal intersects two parallel lines, then corresponding angles are congruent. First of all, we need to know, okay, parallel lines are two lines that never touch. Okay, we saw that in previous lessons. The transversal will cross both of those lines, and it can be in any direction as long as the line touches both lines. Corresponding angles are angles that when you form the transversal, if you were to cut this piece and move it here, then they will fit. Like this is a corresponding angle to this one. This angle right here will be corresponding here. This corresponds here, and this corresponds right here. So each corresponding pair of angles are congruent, meaning that they have the same measurement. Okay? The next one says alternate interior angle theorem. Theorem means that you need to prove, just like we did it with the vertical angles, you need to go step by step to prove that it's true. And so it says if a transversal intersects two parallel lines, the same thing, right? Then alternate interior angles are congruent. So first of all, alternate means that it's to either side of the transversal. One is on one side and the other one is on the other side of that transversal. Interior because it's inside of the parallel lines. Okay? External will be here. Internal is inside of the parallel lines. And angles, well, it's just angles. So basically, I always say that these type of angles form like a Z. If you notice, in here it says that angle 3 is congruent, angle 1 is congruent to angle 3. Those are the alternate interior angles. So this is angle 3, this is angle 1, and so if you extend them, they form the letter Z. And sometimes it's going to be backwards, but it's still the same shape, okay? So angle 2 and this other angle are also alternate interior angle because they're on both sides of the transversal and inside of the parallel lines. And they are always congruent as well. Oh, I wanted to point out also that in here, I said, oh, this is like a pair of boots. And I was thinking of Peppa Pig's boots when she goes in the muddy puddles. Okay, two boots that are aligned, facing the same way. So those are corresponding angles. Same side interior angle theorem. Again, this can be proved. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. So notice how for these two, they are congruent. For this last one, they are supplementary. Same side means that on the transversal, we have this angle 2 and this angle 1. They're on the same side of the transversal, okay? And the same side interior angles always form a C, letter C. How do I relate these ones? Well, I always think, oh, alternate interior angles. A is the first letter of the alphabet. Z is the last letter of the alphabet. Alternate interior angles form the letter Z. Same side interior angles. Oh, the sound same, C, same. Okay, letter C. Maybe that'll help. And for this one, I just noticed that it has double R and it kind of formed like double L, the shape. Okay, so maybe that can help you remember the shape of the angles are L's, double L, and you have double R in the word corresponding angles. Alternate from A to Z, and same side interior angles have the same sound with the shape that it forms, okay? And so in here, same side interior angles, if this was 60 degrees, then this would have to be 120 to make 180. If this is 80 degrees, then this will have to be 100 degrees to make 180. Okay, so that's what the postulate and two theorems of parallel lines tell us. Actually, let me write. When you have this marking, sometimes it's one marking, sometimes it's two. So you might have another one in there. That means that they're parallel. They're telling you that information, okay? So in here it just says name a pair of, and then this type of angles. So let's see, alternate interior angles. Alternate interior angles. Interior means inside of the parallel lines. Alternate means one is on one side of the transversal, the other one is on the other side. And it's alternate, it's just the Z, okay? So it can be angle 3 and angle 6, or it can be angle 4. I'm gonna actually do this one because this letter Z, which is backwards to begin with, it's funky, okay? So one pair of alternate interior angles would be angle 4 and angle 5, and it forms the letter Z. Remember, from A to Z. Same side interior angles, I will do it in pink. They're on the same side of the transversal, and interior meaning, so it can be either angle 3 and 5 or angle 4 and 6, okay? Each one of those form a letter C. So angle 3 and angle 5. And the last one, corresponding angles, double R, corresponding is double boot or double L. Let me see, I'll do orange. So this one, you're actually gonna have one outside, one in the exterior, and one in the interior all the time, okay? So I'll do 2 and 6, but you could also do 8 and 4, 7 and 3, 5 and 1, 6 and 2, okay? All of those that are, again, if you cut it in here, you pick it up, and then whatever corresponds, those are corresponding angles. So I'm just gonna write angle 2 and angle 6. Okay, that's all you had to do in there. And here it says find the measure of each angle. And I'm gonna explain very slowly what each angles measurement is and the reason, but I'm not gonna write the reason because it's so many of them that I can't write the reasoning behind it. And actually, each angle might have more than one reasoning. Okay, so in here, we have this to be 180 because they're supplementary angles. And so we can say that angle 7 is equals to 102. Okay, the reason? Supplementary angles. Angle 4, if you notice, they form the scissors. So if this is 78, this is a vertical angle and it's the same measurement, so 78. So hopefully, and actually let me zoom in. We have 4. If we had to cut this in here, okay, the 4 corresponds to 11, and that's 78 degrees. The 7 corresponds to 15. That's 102 degrees. Let's see. I think I want to do something different. In here, we have number 7. It's congruent to number 10 because of the alternate interior angles, A through C. Okay, alternate interior angles make him congruent. Okay, and number 14, we can say that is corresponding to the angle they were giving us. So it's equals to 78. Number 10 and number 3 are corresponding angles. So the little double L's backwards. So this is 102 degrees. Oh, again, remember in here we don't have the markings. I just wanted to point that out. But they tell us in the figure L is parallel to M and T is parallel to W. Okay, so that's why we're following all these same rules. These are same side interior angles, the C. That means that they add to 180. So that's 102. Together they make 180. This is another same side interior angles. Same side interior angles add up to 180. So this is going to be 78. Or also this supplementary. These are vertical angles, or you can do corresponding angles. Either one is fine. So this is 102. These are supplementary, or these are vertical, or these are corresponding. Okay, so several options that you end up getting 78 anyways. Okay, what else can I do? Again, let's do same side. That means that they are supplementary. So if this is 78, this is 102. Or you can just think of this as corresponding angles. Notice how they are congruent. Okay, so different ways. This is 78, corresponding or supplementary. These are vertical, 78. These are also vertical, so it's 102, or you add them. This can be supplementary also, meaning that if this is 78, this has to be the supplement, meaning 102. Okay, so last but not least, we're gonna do a proof, because that's what geometry is all about. Proofs, making sure that you know where they come from. And it's half completed already, so you get familiar with this. So again, we're using the two-column proof of alternate interior angles theorem. Given, they're telling us that line A is parallel to line B. And I guess with transversal, but it doesn't have a name. And we're proving that angle 1 is congruent to angle 3. Okay? So, line A, the statement is line A is parallel to line B. Reason? Given. Angle 1 is congruent to angle 4. That's the corresponding angle postulate. Remember that we're not supposed to, we don't need to, when it's a postulate, we don't need to prove that. That's just because it makes sense, because they look alike, because if you measure them, they have the same measurement. So that's a postulate. You don't need to prove it. It's just common sense that it's true. Angle 4 is congruent to angle 3. And what is the reasoning here? Angle 4 and angle 3 are vertical angles. We already had the theorem of vertical angles. So because of the vertical angle theorem, that's true. Finally, it says that angle 1 is congruent to angle 3. Notice how in here we have that angle 4 is congruent to angle 1. Okay? And that's because of the corresponding angle postulate. And also that same 4 is congruent to angle 3 because of the vertical angles. So it's like table 1 looks like table 4. Table 1 looks like table 4. Therefore, these two are the same. And that's called the transitive property. Okay, and therefore we have shown that, yes, alternate interior angles are congruent. Along and do your own pictures. Vertical angles are congruent. They're opposite of each other. Okay, so these are a pair of vertical angles. These are a pair of vertical angles. So whatever is on one is equal to the other. That's how you can form an equation. This equal this. Okay, like if they have an algebraic expression. Adjacent angles are next to each other and they're supplementary. I call it the half orange. Okay, they're always supplementary. You always have to put this expression plus this expression equals 180 degrees. Corresponding angles, so the rest I think come from the rest come from the parallel lines. So corresponding angles, each color corresponds to each other and each one is the same measurement. Each color has the same measurement, okay? They're congruent. So if this is, let's say, 70 degrees, the other purple one is going to be 70 degrees. If this is 110, the blue one, then the other blue one is 110. So that's for corresponding angles. They form like double L, double L. Double L facing down. Double L facing down, but starting from here. Double L up and like one on top and one on the bottom, okay? Corresponding double L, double R. Same measurement. Same side interior angles, those will form the, they form letter C. They add up to 180 degrees. And I didn't mention these ones in the theorems, but you have same side exterior angle. Those are also 180 degrees, and yeah, we didn't go over those in the lesson, but you have them and it's 180 degrees. Okay, the last two is the alternate interior angles. That's from the A to the Z, remember, and those are also congruent. And these are alternate exterior angles. They're also congruent. And notice how they are almost like vertical angles. That's what students came up with. They're vertical angles, but far apart. Okay? So this is like if we was here, those will be vertical, but in reality it's far apart. So those are also congruent. Okay? So I hope this summary helped you, and sorry for making this video too long, and have fun.